officially get the event started. So hello everyone, this is Maggie from Codementor, and the event today right now is Future of JavaScript, Debugging, Dbux, and Dynamic Program Analysis. And it is part of the Developer Growth Summit 2022. There will be additional announcements at the end of the talk, and we will also be posting a link to a survey that Dominik would like to get your opinion on. So please stay around during that time to help Dominik knows what you think about his talk. And as you probably noticed, we are using Zoom webinar for this event, and it is completely normal that you aren't able to see the other attendees. But it's completely okay. Please know that a lot of you are actually here with us. So feel free to interact with each other through chat. Just make sure to set it to send everyone since it defaults to host and panelists. You will also notice at the bottom of your Zoom webinar, there is a Q&A box. We encourage you throughout the event, if you have any questions that you wanted to ask Dominik, please put your questions in the Q&A, as we do have a Q&A sections at the end of the talk, and we will then try our best to get to your questions at the end of the Q&A. Another thing that I wanted to bring people's attention to is please keep your languages respectful, encouraging at all times just to make sure that the event is enjoyable for everyone. We will also be posting a link to our code of conduct in the chat. So if you have any questions about that, please check that out. And without taking too much of the time, I want to officially introduce Dominik, our speaker for the event. Dominik is a developer, coach, and PhD candidate researching interactive debugging techniques. He's dedicated to solving complex problems and sharing knowledge. So I think he's definitely a great person to speak to us today about the topic of debugging today. So without further ado, Dominik, please take it away.
Thank you, Maggie. Hello, everyone. I can see Michael and Richard saying hi. Hello over there. Jade also. Yeah, all right. Then I'm just going to share my screen. I'm going to get started right away. Let's see how we can do that. Guessing that's the share screen button right here. Go. All right, there we are. That's it. Now you can check out Dbux. We will post a link in chat later. We'll just do that later. Okay, let's get started. Okay, so first of all, I will discuss basically things that are kind of applying to all of debugging. That's my kitty cat right there. Sorry, he likes the attention. And it is not just JavaScript debugging, as it turns out. It actually happened to become just basically all of debugging. All right, let's go. So this will be our outline. How do we usually debug? What is the debugger and what is dynamic analysis? I'm going to introduce my tool and then yada yada yada. The future of debugging. All right, we're gonna finish with that. All right, let's get started. How do we usually debug? That was the question earlier. That's not really a question that has an easy answer. I think we kind of have to spend a lot of time to even consider, okay, what are all the bugs we had and what is actually difficult? And I think that has to do with the fact that we don't really usually talk about bugs or debugging, as a matter of fact. I'm going to actually start my timer here real quick. Sorry about that. And but it is, I think, worth noting that there are a lot of bugs that are very easy to fix, but they are just difficult to find. And this is what this is all about. Today, we're talking about how to find bugs, not how to fix bugs, okay? And so what makes them difficult to find? Well, what is debugging, right? Debugging is a search problem. We have tens of thousands of lines of code, maybe more, maybe less. And we are trying to find that one line that's buggy. That's maybe it's an overgeneralization, but of course, many times there's actually just one line that causes us all that trouble. And it's like finding a needle in a haystack, just tens of thousands of lines of code. One of them has a bug. That's a needle in a haystack problem. So another way of looking at it is, well, it's basically a complicated program. A complicated program is like a factory. It is this big, messy place that does all these complicated things. And where are we? We are sitting on the outside looking in. We are not really looking at what is going on inside the factory. We don't really know what the dynamic runtime behavior of our applications is, because it's just the tools we have are just so bad, really. They don't give us the information that we would need. So what do we do instead? We look at the inputs, we look at the outputs, all the things we can see from the outside, and then we try to assess what is going on inside. Another thing that we do is, well, we have the source code, right? The source code is kind of like a blueprint. So what do? We just stare at the code. That's like #1 debugging technique right there. Well, something went wrong. Let's look at the code again. The second debugging technique is probably our fax machine. I want to call it a fax machine. We have a little bit of a sensor in our factory hall, right? Remember the factory metaphor. We have a program that's running, and we hook up some sensor, And to the sensor, we hook up a fax machine, and then sometimes it tells us a little bit about what's going on inside of the factory. That's kind of like what a print statement is. And then we have the traditional debugger. Some people use it, some people don't. Doesn't matter all too much. We will discuss its shortcomings today. It's a little bit like taking a flashlight into this really dark factory. It's actually, the lights are not even on, and trying to find this bug in the corner somewhere by basically scanning the floor, like this ginormous factory. We're trying to find it with like basically a flashlight and a looking glass, looking for that bug. That's kind of like what the traditional debugger is. All right, and so these are the three main tools for debugging, it appears. So what could we do? Right. Well, first of all, let's consider the problem. The problem is the dynamic runtime behavior is not our code. Our code is not our runtime behavior. The thing that we look at the most, the code, is actually not all things that are really that would really matter to us. The things that are actually happening inside of the program, we don't really know. We don't really know what is going on in our program most of the time. I mean, we can think about it. We can use our brains to reason about it, but most of the time, most of it is invisible, intangible. We cannot see it, we cannot touch it, right? These little graphics there. But most of the time, we have to kind of reason about it using our brains. That's what the mental model thing is all about. And funnily enough, 25 years ago, a very smart man called Lieberman from MIT already pointed out, well, we should have better tools to help us reasoning about the dynamic behavior of our programs. We should have better tools for that. Well, nothing changed. Nothing has changed in these 25 years. I mean, something has changed. There's a lot of research going on, but in the industry, no. We, as a developer in our day-to-day work, we still don't have these tools. All right. So another thing that we're lacking is this sort of debugging culture. And that is what I talked about earlier. What was the last bug that was really easy to find, really easy to fix, but difficult to find? This kind of question, I don't know, to me, isn't this kind of like a question that we would like to talk about in our professional environments? I would say so, because ultimately we spend a lot of time, a lot of energy on debugging, but we don't talk about it. How much time do we spend talking about debugging strategy or debuggability? Well, and to be fair, we talk a lot about testing and testability, and that's certainly a good step. But debugging is still yet another step. Even if you have a lot of good testing, I would argue you still need good debugging on top of that. All right. And then how much do we talk about dynamic analysis, if at all? How much do beginners spend on learning to debug? And as a professional, how much time do you spend on improving your debugging skill versus, well, learning all kinds of other skills related to programming? Even though debugging seems to be this thing that is actually consuming a lot of your programming time, I would argue. And so would researchers, by the way. A lot of researchers have also found that on average, the programmer actually does spend a lot of time debugging. All right. So what can we do about it? Well, we can have better debuggers. So we're going to talk about better debuggers. We're going to talk about what kind of questions we usually ask during debugging. We're going to talk about dynamic analysis. And ultimately, we're going to talk about how the debuggers can help us use dynamic analysis to answer debugger questions. All right. Number one, what is a debugger? All right. So all types of debuggers is this, right? So I'm going to make this little diagram here. Of that, some of them are interactive debuggers. And of that, there's that traditional debugger, which is usually called the debugger. That is just one instance of a debugger, okay? I want to make that very clear. We have, generally speaking, there's actually three types of debuggers. Number one, we have automatic debuggers. Again, this is just basically research. There's so little of that happening in the industry, where you have debuggers that automatically determine where your bug is with some, with some amount of success. Semi-automatic debuggers that kind of try to find bugs automatically, but they try to use your brain power to help them find it, basically. And then there's the interactive debuggers, and those are the ones we are talking about today. We are talking about interactive debuggers as a whole. We are not specifically talking about the debugger, right? I want to be very clear about this, which I call the traditional debugger. I also call it the BVCF, the breakpoints, value inspection, call stack, and forward stepping. Those are the main four features of the debugger, aka the traditional debugger, right? Breakpoints, value inspection, call stack, forward stepping. Great. What is a good interactive debugger? What could we do on top of all of this, right? Well, we can have a better tool such as this one. This is a good interactive debugger. If your problem is a needle in a haystack, a metal detector is a good tool. If your problem is a needle in a haystack, a magnet might be good. Anything that acts with metal is going to be a good tool. Question, why don't we have them, right? They're going to ask this question again and again. All right. So a good interactive debugger has the goal of helping us illuminate this dark matter of debugging. All these things that we don't know about, the things that are going on in our programs that we don't know about unless we specifically prod and query every single part of our code to basically give us the answer one little step at a time. It's not a very efficient way of doing it, right? So what we want to do instead is we have this interactive debugger that can somehow make this whole dynamic runtime behavior visual and interactive, and makes it a lot easier on our brains to build the mental models, and probably makes it a lot more efficient. And as I argue, or at least, okay, in my opinion, it also makes it a lot more fun. All right. So what does an interactive debugger look like? Actually, this is this bar there. There we go. All right. We have the source code, and then we have a system that we want to run it on, right? So then we run it, we load it into some process or multiple processes, and then we have an application that's running. And then we have a debugger backend. So the debugger backend is somehow connected to the application and the system using, number one, a control module. Not all debuggers have it, but the traditional debugger, for example, has a control module. So you can, for example, start, stop, break, and the application set breakpoints and step through it. This is the control module. And then the application, the system can send you all kinds of data, right? And then we can just kind of grab that data, put it in our dynamic analysis engine, put it into this sort of data repository, which has these really powerful, awesome queries on top of it. And then we can just ask the dynamic analysis engine to give us all the information that we possibly would need regarding our code, either as a whole or in regard to every single line of code that we're interested in. And then on top of that, of course, we have a front end where we have a visualization of this data that we find, and hopefully very powerful features to allow us to interact with it. Oftentimes the debugger front end is connected to the IDE. It doesn't have to be. The IDE, as well as the debugger front end, might need access to the source code to connect the data back, to actually map it back to the source code. And that's it. That's basically the model of an interactive debugger. Now, some examples. I apologize. I have some things loading on my screen. I'm not used to. I'm gonna move some things over here. Try that. Okay, I'm just very sorry about that. Just very quickly. There we go. All right, this is good. Okay, great. All right, now things are a little bit off the way. Now, so what are examples of that? The traditional debugger, for example, as I mentioned earlier, has the control module to kind of like allow you to step and do the breakpoints and all that. It has a very, very simple. I don't want debugger developers are not gonna like what I'm gonna say here, but the dynamic analysis engine of a traditional debugger is just not very, it's not very good. It doesn't have a lot of features, let's put it that way, compared to what it could do. Now there's the profiler. The profiler is also sort of a debugger, a performance debugger. It helps us to, it collects all kinds of data, such as all the function executions and their timestamps, and then allows us to reason about what took how much time. They put it all on the timeline. That's part of its the visualization of the profiler is this nice timeline and these different views of sorting things out and so on. And then you can ultimately find the bottleneck in our application through that, because there's also some cool interaction features, like you can sort things and so on. All right. A coverage reporter also kind of falls into that. It kind of tells us about which lines of code executed, maybe how often they executed and so on, how they connect back to our test cases. But it's basically the same thing. It does dynamic analysis more than anything. And then we have Dbux. This would be the example of this experimental debugger that I've been working on for a while. We will look into that in a second. All right. There's a lot of other things that you can do. Like awesome debuggers don't have to necessarily have strong dynamic analysis, but you can also do all kinds of other things, such as in this space, replay is a really awesome thing that you definitely want to check out if you are serious about debugging JavaScript. They have become pretty mature. They allow professionals or any team to work together on their code and on individual debugging sessions, which are then sitting in the cloud. So then they can basically have that integrated with their CI. CI is running, test fails, the debugger session is created, automatically put in the cloud, a link is attached next to the failing test. You can jump right into it and you can work with other people on debugging a single session. Very awesome. Replay does a lot of cool things there. A little shout out right there. Now, This talk, though, focuses mostly on dynamic analysis engine, on the visualization and the user interaction features. Okay, this is what we really like. This is kind of like what's missing. This is really what has been missing for the longest time. All right. So now we're going to talk about what kind of questions do we ask when we debug. And we start off with a simple, well, simple quote unquote example. Let's say you have this abstract piece of code and you have a bug report, okay? A gets printed, but it shouldn't. Line 18 executed, but it should not execute. All right. So, well, first of all, maybe what is a good question to ask? Well, what is A's value, right? And you will find out if you run this whole thing in your brain, right? This is how it works, right? You look at the source code and you start, run your compiler and your interpreter. You run the code in your brain, and that's how your debugging process does most of the work. And ultimately, you will find out, okay, A's value will be 0, not too hard to find out. And then if A does not get printed, and you can start reasoning about that, what is its value then, and so on. But ultimately, we want to ask, why does line 18 execute? And then it also becomes more of a question of which lines affect line 18, because now the debugging process is kind of like about, a lot of it is backward reasoning. You see a symptom, and then on the timeline of the overall program, the symptom is always going to be later. It's going to be after the actual bug occurred. So the bug will always be, I guess the camera's switched around. Okay, it doesn't matter. Okay, on the timeline, the bug symptom will always happen later than the actual bug, right? The thing that you see is just a symptom, but it might be caused by any number of reasons before the bug happens. So a lot of debugging is backward reasoning. So now we need to understand which lines affect line 18. So, for example, in this case, we look at the if here, and then suddenly the question becomes, well, why is this condition, which is not A, true? Which also means, why is A falsy? Now, this is a branch problem because what you actually do is, the first step you do is, you determine under which condition does this code execute, which means you want to be aware of your branches. This is going to be a recurring theme. If you know your branches and you know certain other things, you know everything you need to know about your program. So the first thing is you're going to jump to your branch. You're going to find out, okay, it's all about the not A, and then it becomes about A. Why is A falsy, right? So where did A come from? And suddenly your original problem, which was why does line 18 execute, became a branch problem, right? Which branch is controlling or dominating it, and becomes a data problem because every branch is always controlled by data. So ultimately, a lot of your problems are always going to come down to these branch and data flow problems, and that is dynamic analysis, right? Then we're going to keep going up the stack, right? We see F has executed, so we go to whoever called it. Maybe we can guess it. Maybe we need some other tools to determine where it actually got called from. A lot of the times we don't actually know where the function got called from because it's getting called from so many places. And then we up here. And then we can ask other questions such as, okay, we have all this stuff here, right? So for example, line 5, 6, 7, G1, G2, G3, how do they affect line 18? And it turns out not at all, right? Another thing that you could ask is, does line 9 affect line 18? Like this whole if, and it turns out it doesn't, but you don't know that. This is, interestingly enough, determining whether or not this if executed. If we ran the whole program and then do backward reasoning, we can determine that this did in fact not execute. But this is hard for us, but it's super easy for the computer because the computer ran it for us. The computer could just like remember a little bit of data over there, could send it to our dynamic analysis engine, could tell us, oh yeah, this didn't execute. And suddenly this whole if could be hundreds of lines of code is eradicated from our search. So a lot of things that are hard for us are easy for the computer. And then line 18, line 17, line 13, and line 2. Those are the 4 lines that really affect line 18. That's what it turns out to be. If we look at this, the Y doesn't affect it. These things cannot affect it. This is just basic JavaScript semantics. There's no way that this could somehow affect the value of X. And because it cannot affect the value of X, it cannot affect this branch. And that's why it cannot affect whether or not this executed or not. Ultimately, G1, G2, G3 can be eliminated from that very easily. Very basic dynamic analysis right there. All right. So just a little side question. What's a branch? Any idea? Anyone in chat? Anyone? What's a branch? Real quick. It's like, well, maybe we can have some interaction or something, What's a branch? I'm not sure if everyone can hear me or if like everyone's like, I don't know how to use the chat window, or maybe it's like, well, that's not fun. I don't want to say that, or Okay, I'm going to move on. We're going to see if there's kind of interaction. One of the possible paths the code can go. All right, you can say that. Yeah. No. Yeah. Different routes. So an if-else statement. Yeah. If-else. Okay. Okay. This is interesting. If-else. So syntactically, what are the syntax? What kind of syntax elements are branches or inducing branches? Yeah. Data-driven decision for the program to switch paths. Yeah. What is the syntax? What kind of syntax elements do we have to look out for if we're looking for all the branches? If, for, ternary statement. Yeah. So Sophia. I hope I don't butcher that name. Control flow elements. Yeah. So there's that way. There we go. It's all right. The switch case. Okay, that's good. That's also awesome. I think Sophia. I'm sorry, I don't know how to pronounce your name. If your loops, your ternary statements, your switch cases, and most importantly, and that's all. It's easy to forget, your function calls. Okay, so your function calls are also branches or inducing branches, depending on how you define it. So you want to be aware of those things. Those will determine how your control flows through the program. All right. Okay, okay, let's continue. So I'm just gonna throw a whole bunch of questions at you, right? And you can see how you feel about these questions. Are these questions that you are sometimes asking in your process of making sense of your program or when finding bugs? Why? There we go. There's my timer. All right. Why does this expression variable have that value? Where did the value come from? Did this branch get executed? Which functions were called prior to this thing that we're looking at? Where is X happening in relation to Y? For example, where if I see function f executed, how did function g execute in relation to f? Because clearly f depends on that stuff that g does. Then g is way over there. It's just way over there. Camera's terrible. F and G have a large distance between them, and they depend on one another. And you need to understand their relationship. That's oftentimes a very clear thing that we want to do. For example, we want to render a component in any front-end framework, React, whatever. And then we want to fetch data from the backend. And the data was fetched and was committed to the state management system. But for some reason, C did not pick it up. Why, right? So you want to know how these events interrelated and why the one thing did not pick up the other, and so on. Which lines of code are responsible for drawing this pixel on the screen? Of course, for this, these days we have pretty cool browser dev tools to help us, for example, but in other languages, we don't. Which function executions are affected by this value, right? This is more of a downstream kind of questions. Interesting, because usually, again, we backtrack, but here we actually go, sometimes we might go forward, but usually we backtrack. And then who resolved that promise? Because, well, I don't know why, I'm awaiting, but for some reason, await already like stopped awaiting and now it does the thing, but the promise, it shouldn't have resolved that early. And so for Dbux example, in Debux's case, we have some cool tools that help you deal with that, for example. All right, Dbux is a little debugging. No, it's a little icon I made. Okay, whatever. Introduction to dynamic analysis. Actually, we just did it, right? We just went through basically all the major concepts of dynamic analysis, right? Dynamic analysis mostly is dynamic data flow analysis and control flow analysis, and then there's other names that can throw in like dependency analysis, and so on. But that's kind of what it comes down to. There's your inputs and outputs on the data flow side of things. There's your inputs, your outputs, your arguments and return values, your data reads and your writes. If you're aware of how all of these affect your variables, you can very quickly make sense of your code. Control flow analysis is then basically branch analysis plus data flow analysis. That's what control flow analysis is. And that kind of tells you, okay, how did the code execute? Where did it take this turn? Where did it take that turn? And so on. And then again, we asked earlier, what are branches? We just discussed that. Don't forget, function calls are branches too. Function calls, especially in OOP, actually even in functional languages, you have that a lot, where you don't really know what the function was that you called. You called the function, but it turns out, oh, it actually called something entirely different from the thing that I wanted it to call. Yeah, all right, there we go. So in order to answer the question, what is dynamic analysis? This was the example we just worked through. And this was also an example of what is called a dynamic slicing. This is just a basic dynamic analysis technique. Slicing means I'm going to take a program and I'm going to take like some line of code. And I want to make sure that that line of code does what it does. And it definitely does that thing correctly. But I want to eliminate everything from the program that does not affect that line of code. And that's exactly what we just did. If you have ever posted a question on Stack Overflow, you will probably have gotten downloaded for the reason that you did not do dynamic slicing. Meaning you did not produce a nice little simple example of your code, but instead you just threw the whole code on there. Because the first time you ask a question on Stack Overflow, I don't know about you, but that's how I kind of got started in programming. Long before Stack Overflow and IRC, that's when I asked my questions. I would just like throw the whole thing on there and hope that someone interprets the whole code for me. But no, please slice your program first, give a minimal example of it, and then people can help you debug, and you can help yourself debug. That's actually part of why it's a requirement. So you can help yourself debug. Turns out we do that all the time. In 1982, this guy Weiser, his name is Weiser, you know, he figured out already that programmers use this slicing technique when debugging. People who were better at debugging consistently used more slicing than those who did not. The concept of basically eliminating all the code that is not related to the line of code you're inspecting or investigating. Absolutely crucial concept in debugging. That's why I talk about debugging skills. I love talking about debugging skills and dynamic analysis, because it's just it can do so much for us, I believe. All right, so how can interactive debuggers use dynamic analysis to answer debugging questions? Well, let's just jump right into it. So what I'm going to do is I'm going to skip over that question. I'm going to come back to that, and we're just going to look into debugs. I'm going to just give a quick demo of what we can do with debug. I'm going to look at my timer. Time is running out. Let's go. All right, nice little example right here. So I don't know if someone from the staff could like put the link back in, the Dbux link. So anyone who wants to try it out, just try it out right now. It's a VS Code extension. You just install the extension. You click the start button, and that's it. That basically you're in. Then you can run some program with it enabled. So for example, I just ran this thing here enabled with Dbux enabled. It's important that you need to enable Dbux when running it. Just like you need to enable your debugger when running your program in order to debug it with any other debugger. And so I'm going to enable this, and then we go. So this is a little bit of a visualization. I'm not proud of this visualization, but it kind of shows you what executed and what did not. Everything that did execute has some icons next to it, and like it kind of shows you a little bit about how it executed. Let's say I want to figure out what this thing is. I don't know what the Y is. I'm just going to select it. I'm going to put my cursor on it. I'm going to select it with this button over here. I'm going to look at trace details. Put this up. I can inspect everything related to Y. Okay, so I can see it has the value 1. It executed 4 times. First time it was value 1. The second time it was value 2. 1, 2. This is all the values of Y. This is a very simple, stupid test program, right? This is why this doesn't seem to make a lot of sense. We're going to look at a real world example in a second. And then over here, we have the call graph. What is the call graph? The call graph is the generalization of the call stack evolved over time. The call stack, I hope you have seen a call stack before. If you have not, let's talk why you want to use a call stack. If you have ever seen error message, the error message usually gives you a call stack unless you screwed it up or someone screwed it up in such a way that you were not given the call stack. You only saw the message of the error, and the call stack was gone, and then suddenly it can be very upsetting. Anyway, the call graph is the generalization of the call stack as it evolves throughout the whole thing. We can kind of open it up one by one. So for example, initially you only see basically everything that's executed on an empty stack. So we have the entry point, call graph 1.js, and then we have 2 set timeouts here. Set timeout executes on an empty stack. So oftentimes when we have set timeout or anything else that is asynchronous, suddenly we lose the call stack. It's terrible because our tools are not that good. Just basic things like give us the complete call stack. It doesn't do that. Suddenly you lose your call stack because you have used a promise. And you don't know where the promise was triggered from. Dbux helps you with that. Okay. And so you have the call stack here, the call graph here, all the things that happened on empty stack, and then we can just open up everything, and you can see, for example, what happened. The timeline is vertical, so pointing down, just like your code, right? The first thing that happened is we got into call graph 1.js, then F got executed once. From F, we executed G twice. So by the way, F is here. We executed G twice, 1, 2, and we can also click into it, or we can click the call expression here. It was G was executed here once and another time, and then F got executed another time here, over here. You can click on it and you know where it is. And then from there, G got executed again twice, and so on. And you can like close this up and just investigate it step by step and so on. All right, there's all kinds of things. We can like see the location in the code. we can see a call with the inputs and the outputs. Like, for example, f was called with x equals 1. We can see that here. And then with x equals 2 and so on. And then we can see, oh, sorry, that's not what it is. This is the call expression. Sorry, this is this thing. This is f1 and this is f2. I'm so sorry. Oh, anyway, so here's the value. All right, so this is the value. These are the inputs and the outputs. So f here got called with the first argument, or the first parameter 1, and the result is f1. This here, this is actually, it turns out, if you go here and you click that, it's f1. That was the output. That was return value of this function. You can just see all your function calls, every single one of them, and their inputs and their outputs. All right, and then we have some stats, like how many times, how many functions, files, modules, and just generally the size of your trace log from that function call. You can see that. All right, that's it. Yeah, all right. We can also see some global information, like all the errors that were thrown, all your console statements. You can click that, oh, sorry, all your console logging. You can just click them individually. It takes you to where it logged it. And then, of course, from there, you can keep investigating. Oh, how did that happen? Well, you look at the call graph and tells you exactly how this console log statement came to be and so on. So it shows you all your recorded packages. We don't have any, and so on. And then we have search results. Yeah. All right. These are like the basics. Now, the call graph is, I think, a really powerful tool. It gives you a map. It's like playing a game. Like, and I think debugging without a map feels a little bit like playing an open world game without a map. You don't know where you are, and you have to remember all the time, at every point in time. You have to remember. You have to, have to really rely on your big brain and your mental models to determine where you are. Now, this is great if this is code that you have been written, that only you have been writing for the last 5 years. This is probably not too much of an issue. But now suddenly you have a dependency problem. That dependency, that library that you have been using for 5 years suddenly has a bug. You never looked at the code. You don't know how the code looks like. You have to jump into this library. You don't know anything about it. You don't have a map. You don't even know where you are. You're just trying to debug it and you don't even know where you are in this ginormous library that might have thousands, tens of thousands, hundreds of thousands of lines of code. And so having a map is just awesome. That's why I called it a map. It's kind of, this call graph kind of gives you a sense of all the things that happen on a singular timeline with all the caller-callee relationships. All right, let's jump into the real world example. I'm wasting way too much time on this. Let's look at this here real quick. All right, here we go, 5 minutes, let's go. So here is to-do MVC. Let's have a look at this. If I can find it real quick, move this over here. Perfect, okay, I hope you can see it. This is to-do MVC, right? What do? I can enter some information, I can click some buttons, and every time I do anything, code gets executed. I want to know what happens when I click a button, right? So I come back here, I look at my call graph. I'm going to close everything down. Actually, I'm not too sure why this is all open up. And here I'm going to do it again. I'm going to click something, and new events coming in, and I can click this event, for example, and I'm going to show some stats, right? So, for example, some events executed that didn't do really anything, and then some events executed that did a lot. And you can very quickly see from the call statements and from the function names what actually happened. So let's look at this, for example. Let's jump to it. This is a general dispatch event, like hub function. You're trying to understand, what it did. Well, number one, you can see all the functions that were called, and transitively. And number two, you can also select anything. For example, you can select the selector over here. You can look at this is the toggle. This is the value of toggle. This got called 13 times. This function got called 13 times. One time with the value toggle, and then with all these other things. So this is basically me clicking the toggle element, which is like this button to toggle the to-do element and so on. And then we can see further down below that, for example, here's a function called filter. I usually rename it. I don't know why they called it filter. It's basically a render function. I called it render in most of my other examples. This is the render function. This actually does the actual rendering. After you have toggled something, you re-render everything. And then you're trying to find out, okay, what is actually happening here? And you look at this, oh, well, it gets some data from the store, and then it shows items of data. So it renders it here. You can click on data. What is this? What is data? All right, well, let's have a look. Value, open that up. It's an array and with 4 elements. And the last one is ASD. And the third one, and you can see these are the to-do items. Interesting. And we are rendering those. And then we can kind of like jump in there. Okay, so over here we have controls. We can now jump around just like with the traditional debugger, but we can go in both directions. We can go backward, can go forward. So we can now jump into that function. go down the call graph. Sorry about that. Sorry, clicked the wrong button. Yeah, go into the show items function, and then furthermore, we see that an inner HTML function. That the inner HTML here is being set. It's compiled into some sort of string over here that will then be stored into the inner HTML of the to-do list. The item list function creates that HTML string for us. We go into that, and we can investigate everything over here. Again, we're just gonna, select this thing. We're gonna see this is the value of it. Can actually open that up, open an editor because it's so much. Okay, this is the HTML of the entire to-do list. Great. And we can do all these crazy things with it. All right. Quickly, data flow. All right. So we can, for example, say, okay, this is the item title, or this is an item, an individual item. And we can look over here, and we can see all the places where this item went, where basically this object or this value, this value, was read or written to. And we can see, in all kinds of places where, escape for HTML in this call here, in the template. So a lot of this is in the template for rendering. But then if you keep going up and up and up, you will find its origin. You will find the data origin. Where did item come from? Well, turns out it came from local storage. All right. So if I click this, all right, this is where it came from. Local storage get item, JSON parse. Okay, this is where the to-do item came from. If I click a new item, see if I can quickly find one. Let's go back to template over here. Here. Yeah, that did not pan out so well. There we go. Sorry about that. Show items. This is not that one. Okay. All right, trace details. We're going to go back into it. Apologies. There's definitely faster ways of doing that. I just forgot that I could just go backwards. Okay, sorry about that. Okay, so we find an item again. We look at this. This is to do one, for example. And then you can find, for example, this is the last item, the one that I just created, right? I'm going to go look back at the data flow. I'm going to find, oh, this had another origin. This had a very different origin because this did not already exist when I loaded the page. That did not come from local storage. But if I click this thing, which again, this is the timeline of all the things that happen to the object, right? So this tells me, oh, this object came from here, from the add item function. This was created over here. There you go. And so this gives us an idea of some of the things we can do. We can do data flow. We can see the entire call graph, which gives us a map. We can click into everything. We can investigate every single thing. Let's see. One thing I wanted to do also is the Fibonacci function. If you have ever dabbled in algorithms because you wanted to get a job, or for whatever reason people dabble in algorithms, let's have a look. Let's bring this up. All right. It might have occurred to you that recursion and algorithms is important to you, and so you want to understand how they work. And so Fibonacci is a very basic recursive algorithm. And as you can imagine, it has an interesting call graph. Let's open it up. This is Fibonacci of 6. All right. So we're going to start that over here. Let's see value. There we go. So we're going to start this over here with 6 as an input. Oh, it has 8 as an output, by the way. And then it called, well, let's actually close this up, go level by level, right? Open this up. So it's, oh, okay. So 6, then called it with 5 and 4, which by the way is 5. The results are 5 and 3 respectively. We're going to open up 5. Oh, that's with 4 and 3, and so on and so on and so on. Open up the whole thing. Oh, what happened there? Okay. And this is the whole recursion tree. This is called a recursion tree. If you ever do recursions, or if you ever do recursions, you want to have this visualization. A lot of other things like graph, any sort of a graph algorithm, absolutely crucial. All right. So 4 minutes left. Let's see what we can do here. All right. Let's get back to this real quick. There's a lot of other things I didn't even get to show you. And I prepared the video in case, something craps out. All right, there we go. So interactive debugging features. So when we talk about the future of debugging, I apologize. When we talk about the future of debugging, what can we expect? What are all the cool things that we could do? And I've looked at the research and I found several dozens of papers that were proposing new ideas of letting developers interact with their code in a new way, or rather specifically with their dynamic execution behavior of their code. And this is what I found. These were the main 7 features that, 7, this is an Asian 7. Okay, so these are the 7 features that I found. So there's, for example, the data flow view that we saw earlier. So you select an object, sorry, you select any value. It could be a 3 or a string or anything, tells you where it came from. And these are the kinds of questions it can answer, right? So this is the one type of feature that I would be looking forward to see a lot more of. This is a terrible data flow view. It's really hard to read. I would love to make this really, really good, with time. I would love to have more people work on things like that, so we can have more and cooler data flow views and better ways of finding the data that we really need and we care about. Control flow maps, right? So we have the map of the normal call graph that one calls another, where one function calls the other function and so on. It's a call graph. But there's all kinds of other maps, like, for example, a basic timeline would just be great. Like the timeline with events on it, like, oh, this is when the user clicked something, and then this is the same thing where the file got loaded. And this is the thing where we got the backend data back, the event timeline. Or, as we see here, an asynchronous call graph that puts together all the asynchronous things that have happened in your program. I hope I can talk about that in a second. Okay, so these are the kinds of questions this would answer. Okay, let's keep going. Dynamic analysis query engine. So one of the most basic things is, I'm not sure if you realize this or if you remember this thing, I just clicked that in order to select something in my code, and it would give me the runtime execution behavior of that piece of code that I selected and everything that's correlated to it. So that's a very basic way of querying, well, basically interfacing with this dynamic analysis engine and asking it for basic information, just all kinds of queries you could do. So for example, one query is, that piece of code, give me all the information that you have, all the dynamic information that you have about it. There's all kinds of other things you could ask. For example, which variables held value X, or what are all the call stacks where function F and G were both in it, right? Because we care, like F and G somehow are connected, but we don't know how. Please give me all the possible cases where F and G were called, and then it turns out usually it should be F and then G on the call stack, but then at one time, oh, it's G preceding F. That's a bug. It's a bug right there. All kinds of really cool queries you could send to the database engine. To the dynamic analysis engine. All right, control flow comparison. I didn't get to show you that, but basically have a way of seeing control flow in one way on one side, and then diffing it, having a real diff tool, and compare it to the same control flow, maybe at a different point in time. We can do that with a call graph. I didn't get to show you that, but for example, you have the render function called once over there. You have it called again over there, and you can see that the first time it was called, it was calling 14 functions, and the second time around it only called 10 functions. And what is the difference in behaviors of the control flow at different points in time? Or you look at a loop. What are all the differences between all the different loop instances, between all the iterations of the same loop, and so on? Comparison tools for control flow, even for data flow, of course, as well. Dynamic slicing tools, we just talked about that. Be able to just very quickly find all the things that affected my code over here. There's interesting work that has been done on that. Debugger for concurrent execution, like async, concurrent, parallel, multi-process, full stack. I have a client, I have a server, they are disconnected. Can I have a debugger that connects the two of them, tells me exactly, I have a fetch over there, and then when I click into it, I want to jump over to the code on the server side, and then can keep going and debugging over there, can keep debugging that specific fetch on the server side, starting at the client, or vice versa, right? Connect everything between multiple processes, or between multiple promises, even between multiple async function execution flows, and so on. Better tools for that. That's what I'm looking forward to. This is the future that I want to see. And then, well, I mean, I'm ending on a very simple one, relatively speaking. That's just backward stepping. You have your traditional debugger that does breakpoints, values, call stacks, and forward stepping. Now you also have backward stepping. That would be great. It would be a great start, because again, where's your bug when you see your symptom? It's always backwards. Your bug is backwards from the symptom. You want to be able to step backwards. That is why the traditional debugger doesn't work, or it's very insufficient, because you only can go forward, but that's not where the bug is going to be, right? So this is my future. This is what I would like to see. And that's basically it. Now, I just would love for everyone, or those who feel so inclined, who would love to join me, fill in this first survey. This would be great. I want to know what your thoughts are on debugging. I want to use this for my research. It's completely anonymous, but if you're interested in this whole project, you want to reach out to me, leave your email. But don't leave your email if you don't want me to contact you. I will not use your email for any other purposes, won't go to third parties, won't go anywhere, will just remain with me. And I will only use it to reach out to you in terms of the items that you yourself selected. Okay, that's it. That's all that the survey is going to ask you for. it's gonna ask you about your opinion on debugging, and then if you want to reach out, then give me your email. That's it. That's it. We're done. I think so. Yeah.
Thank you so much, Dominic. This is such an amazing talk, and I see in a chat that a lot of people are saying they've learned so much here, and is such a great tool. I definitely agree, and also a great tip on dynamic slicing when it comes to posting your code snippets on Stack Overflow. So I see we have a lot of questions in the Q&A, so let's actually get started. So if you have any more questions, feel free to put it in the Q&A, and we'll try our best to get through as many of them as possible. Absolutely. So the first question is from an anonymous attendee. Thank you for your presentation. Can you please make your slides available and also share some resources?
Actually, that's fine. I can just read them myself if that's okay. I think this might be
sure.
I'm very fast sometimes, too much coffee or something. Also, I guess I'm just at my own pace. It's not even as I'm faster. Okay, so that presentation, absolutely. Let me make that public right now. Just do that. All right. And sorry, then you can go ahead and read the next question if you want.
All right. The next question is from Mina. It's a great tool and presentation. In your experience, how do you bring this tool into your everyday workflow? For example, do you use it in refactoring, pull request review, major design sessions?
Yeah, that's a good question. To be honest, we are working on the on these tools to help us, interact with it. As I pointed out earlier, there's these 3 things that we are focusing on, and then there's all these other cool things that can do around it. So Replay has been doing a great job on that. Sadly, Dbux doesn't have this workflow integration up to this pace quite yet. So if you're interested, the best thing we can do is we can just look at your stuff together, and we will just see if we can make it work in your case manually, because I just don't have the time yet to generalize the workflow for all of them, sadly. Yeah. Also, I saw the question: can Dbux be used with React Native? Not right now. Like, the thing is, it won't. I'm pretty sure it won't be too hard if this is TypeScript or JavaScript. It can be done quite easily. It's just, again, might take a few weeks of time, and it depends on how many people want the feature. So what I'm ultimately probably going to do is I'm going to put up some features for voting, and then hopefully people vote. If people vote, I'm going to implement them as I have time. And that's, I think, how we're going to do that. For now, React Native is not working out of the box. I put the presentation, the slides, in chat. I want to also double check there's nothing inappropriate in them, I suppose. I guess I just moved everything out of there that didn't belong in there. Great. Okay, sorry. Yes, go ahead. Yeah. Okay, no, I go ahead. Okay, thanks. Sorry, great. Okay, Richard, hi. Okay, then can debugs be used for native? Yeah, again, not for Java and Kotlin, not right now. Sorry. All right, next. Thanks. And again, so sorry about that. Yeah, thanks for introducing me. Beginner. All right. Used to debugging through print statements. Absolutely, that's what we all do. I want to be able to understand everything better. Having trouble understand the runtime data, associated data structures. Any suggestions? Okay, so how do you learn debugging skills? Great. Yeah, there's just nothing there. I would love to work on some sort of scaffold for that, but again, this is my time. So basically next year, that's what I want to start working on this. But what you can do, I guess the best thing you can do is reach out. So we stay in contact, and I can better understand, because for this is my research. So I would love to talk to people and actually do some sessions on some of the things that I've learned. I know I can already help you with. I cannot help you with everything, but I'm sure I can help you with some things, and we can understand how your process is and what we can do to improve that. And then I can make that part of my research, and I would love to. So reach out to me. That's, I guess, my best question for now. Sorry, the best answer to your question right now. My brain just sometimes skips words. There we go. Okay, YouTube channel. Yeah, no, I mean, not really. I mean, I don't really post a lot of stuff on that. It's just, whenever there's a big thing that I need to announce, this is what I'm using it for right now. So tutorials, sorry, there is actually something in there. So we have some practice exercises that are pre-prepared. There are some bugs here in practice sessions. You can still see this, right?
Yep.
Yeah, good. Okay. Actually, I am in one of the practice sessions right now. This is how I did the to-do MVC thing, right? So here we have 3 things, like getting started. So find longest word length. I click that, and it would just run a sample of the very simple algorithm called find longest word length with Dbux enabled, and allows you to kind of play through it. This is one of the things you can do. Real tutorials, or again, a scaffold, we don't have yet. So if you're interested, reach out. This is what I can recommend you. Reach out, and then we can talk about more what maybe I can do to address your needs specifically, because again, everyone would have maybe different needs here. All right, yeah, we go.
Yeah,
I think these are all the questions.
Yeah. I think another thing is that Dominik, you're also a mentor on Codementor. I think that's also another way that people can reach out to you if they have any questions about any of this. We'll be posting all of these links in the chat, so feel free to stay around and look at all the information right now. I think
if you leave your email on the survey, this is how I would definitely reach out to you. Anyone who does it, I will definitely reach out to you at one point or another. You can leave in the feedback section like more info that what you would like from me to help you with. And again, this will be free of charge as long as it's related to my research. And then the Codementor aspect is absolutely fantastic. And again, thank you for Codementor for hosting all this and basically kind of like funding a lot of my life here right now. I really have to thank them a lot. But that is very expensive, and you only need to pay me money if this is not related to my research. So I want to be very clear about that. Yeah.
Okay. Right. I don't think there's any other questions, so we're officially going to wrap up the event here. So thank you everyone for posting all these questions, and thank you so much to Dominik for giving this amazing talk. And if you still have any other further questions, as Dominik mentioned, feel free to reach out to him. You can fill out the survey, enter your email, or any other sort of ways that we're going to post in the chat. There is also a link to the survey that Dominik mentioned in the chat, so feel free to check that out. And just a quick reminder to everyone that we do have a sweat giveaway going on for DGS. So don't forget to use the hashtag DGS2022 when you post on social medias. You can share your learnings from the event today or just your general thoughts about DGS 2022. Also, if you like to become a speaker at your own event, you can always just check out Codementor Events and submit your idea from there. And our team will review it and we will reach out to you if it's a good fit to help you set everything up. And as you know, there are more events coming up after this amazing event. And the next one, I believe, if Dominik could start sharing, our co-host would be sharing a screen of what the next event will be. And it's called Developers' Role in Localizing and Internationalizing Software Products. And it will happen at 4 a.m. Pacific time, which is about 1 hour away from now. And in the meantime, this webinar will be open for another 5 minutes for everyone to jot the information down, to get the survey link, or to fill it out. But after that, we'll close the webinar to set everything out. Feel free to stay and chat with us, and hope to see you at the next event. Bye, have a good one.
Bye.